that are affecting our atmosphere. One of which is global warming. When we say global warming, is it positive or negative? Who says positive? Who says negative? Okay. Actually, it depends. This lecture would discuss to you that global warming in one way is also positive. Why? Because global warming helps us to be protected from the cold temperature of the atmosphere because of our location from the sun. Without global warming, we would chill to death. So, the natural phenomenon should be, if you have the globe or the earth is actually being enveloped by what we call greenhouse gases. However, there are two kinds of greenhouse gases. You have the natural greenhouse gases as well as the anthropogenic or man-made greenhouse gases. So the ones which are protecting us from global warming or from being so cold in the atmosphere due to our distance from the sun are actually the natural greenhouse gases. And some of the greenhouse gases that are present in the atmosphere would be CO2, CH4, NOx. Now, these greenhouse gases would have certain potential to trap the energy coming from the sun so that we will be prevented to get cold. Now, how does it work? The global warming actually works due to greenhouse effect. So that means the greenhouse effect has to happen first before global warming. So for example, this portion of the earth or the atmosphere is covered, as we have talked about, with O3, right? And this O3 or ozone would be filtering some of the ultraviolet rays, particularly the harmful ultraviolet rays that would be coming from the sun. However, not all ultraviolet rays will be filtered, right? Because some of the ultraviolet rays are needed for us to have utilized in our biological processes. So, the ultraviolet rays are actually classified as short waves. So, these short waves are actually being ignored by the greenhouse gases once they enter the Earth's surface. Because some of it, the good ultraviolet rays, had to touch a black body. What have you learned in physics? What's a black body? The ground is a black body. We are black body. It's a black body if the emissivity is equal to 1. Or that means it is perfectly immiscible. So that means whatever energy you absorb, the same energy will be reflected back. Now, once a black body does it with respect to the short waves, the short waves will now be converted into long waves. So these long waves are the energy that will be absorbed by the greenhouse gases so as to serve as a blanket for us in the atmosphere. So this phenomenon is what we call the positive global warming, brought about by greenhouse effect due to the presence of natural greenhouse gases. However, what is actually happening is the negative global warming, which rises or brings about rising of global temperature that causes climate change and consequently adverse impact to humanity, such as melting of ice caps, flash floods, and then fertile valleys drowned with salt water, etc. How does it work? Or how does a negative global warming happen? Okay, now, going back to the same phenomenon, what actually happens is that you have the natural gases and then also you have the anthropogenic gases. Basically, those coming from, you're familiar with this? Okay? CFCs, and other man-made greenhouse gases. Not to mention that the natural greenhouse gases would also have higher concentration than the normal. So let's take, for example, this one, because this is very popular. The CO2 emission is so high already that it is being pointed out as the source of the global warming, the negative global warming. So you imagine, I think you have seen already caricatures like this, wherein Mother Earth has an ice pack, and then it has a thermometer, then chilling as if having a fever. Now, how does it happen? Imagine that, let's just take CO2. Imagine that the atmosphere is being surrounded by a thick layer of CO2. CO2 contains carbon, so we can say that as if we are having a blanket of thick charcoal along our atmosphere. Because it's too thick, what happens is that more energy will be absorbed, right? Because that's how a charcoal works, right? When you heat a charcoal, it will keep on burning, right? Okay, so you absorb more heat, therefore, at the same time, you release also more heat. And since there are more gases to absorb it, supposed to be, this has to be exhausted out. That's the purpose of the greenhouse effect. But because of the presence of too much of this, what will happen is that it will be retained along the atmosphere. So that's how a negative global warming works. Now, with respect to the concentration that brings about global warming, it has been related to a certain parameter of these greenhouse gases, which we call GWP. What is GWP? GWP stands for global warming potential. Now, just to give you an idea of its capacity of absorbing how much heat, carbon dioxide has a GWP of 1. So, basically, if you have minimal concentration in the atmosphere, that means you only have minimal global warming potential, right? However, as we have mentioned, left and right burning of fossil fuels from vehicles as well as industrial plants brings about very, very high concentration of CO2. So even if the GWP is only 1, if you have too much of it in the atmosphere, that becomes a pollutant. Remember, how do we define a pollutant? Too much of a good thing. Okay? However, it is being enhanced, the global warming is being enhanced by artificial or man-made greenhouse gases, namely this portion. Just to highlight, take note of sulfur hexafluoride. It has the highest GWP, which is about 23,000 GWP. Imagine, that means one molecule of carbon dioxide, its capacity, you multiplied it by 23,500, that would give you the global warming potential of the SF6. Now, another damage that the greenhouse gases give, aside from global warming potential, is another phenomenon in the atmosphere which we call stratospheric ozone depletion. Because most of the greenhouse gases are classified as persistent organic pollutants. Persistent organic pollutant means these are organic pollutants that when you burn or when you increase the temperature, they do not decompose. As a matter of fact, the more you heat them, the more they get intensified. One example of which would be your CFC. If your CFC would undergo photolysis, photolysis means it's the process involving ultraviolet rays from the sun, the CFC or chlorofluorocarbons will be converted to Cl2 and this will damage O3. Later, I will show you the reaction mechanism on how it affects the stratosphere. Now, another example of these greenhouse gases would be the dioxins and furans. Basically, where do you get dioxins and furans? You get them from burning plastics. So dioxins and furans are actually a member of the family of polychlorobiphenyl, which they can exist or they can produce at very, very high temperature, greater than 100 degrees. And as mentioned, if you start burning it more, these types of pollutants, they get more intensified. Then what would be the after effect of this dioxin? For example, simple. Once released to the environment, it cannot be broken down because it's a POPs. And it is hydrophobic. What do we mean with hydrophobic? Okay. What makes it hydrophobic is that it's a nonpolar. So if you have too much of fat cells, what do you think will happen if you get contaminated with dioxins? It will have attachment to your physiological organs. Okay? Then what will happen? You have it already in your body, and since it's a POPs, therefore it will be retained to your body. Now, men have no ways of getting rid of dioxins other than letting it break down in their body according to its chemical half-lives. But for women, we have ways. That's a good news. However, the bad news is the means of transferring it. Number one, you can transfer it to the placenta of a growing infant. So that would affect your child if you're conceiving. And then you can also transfer it into the fatty breast milk. Again, that would affect your child. So that's some of the impacts of dioxins. And what would be the health effects? Simple. Cancer, behavioral and learning disorders, just like lead, decrease immune responses, decrease male sex hormones, testicular and prostate cancer, diabetes, chloracne, sperm loss, endometriosis, that makes it a what? Teratogen, right? And then breast cancer. So dioxin is also classified under PAH or polyaromatic hydrocarbons. Therefore, we can also say that it is an EDC. What's an EDC? Endocrine disrupting chemicals. Because it attaches to cell receptors that are designed for regulatory hormones and enzymes, causing normal cell functions, including the DNA, to go worried or orally. Now, aside from that, your dioxins is classified by Stockholm Convention. It's a group of different countries which have enumerated the list of the dirty dozens. That means it refers to the top 12 hazardous waste. Dioxins is one of those dirty dozen. The next phenomenon that we're going to discuss is stratospheric ozone depletion. Although we have already an introduction of it a while ago, as I have mentioned, just like global warming, it's a naturally occurring process. So you should have two processes that are occurring simultaneously in the atmosphere so as to maintain a certain thickness of ozone layer that would cover us and protect us from the sun. What are these processes? One would be the stratospheric ozone formation. How do you have it? You have the O2. The O2 will be broken down by at least 200 to 400 nanometer. That's equivalent to the wavelength of ultraviolet rays to form a radical of O. So a radical of O is called nascent oxygen. However, since it's a radical and oxygen is all throughout the atmosphere, the O will react with O2 to form ozone. So that's the ozone formation. However, as we have discussed, too much of ozone in the atmosphere is not needed because it may cause us the tropospheric ozone as a pollutant. So what you need to do, what the atmosphere needs to do is to destroy some of this ozone. So you have the ozone destruction. It goes like this. Again, you need an ultraviolet ray or ultraviolet rays from the sun to break down the O3 into O2 and O. And then the O and O3 will combine to form molecules of O2. So again, these simultaneously happen with the presence of UV. That's why this process is called photolysis. Now, what happens if you have photolysis in the environment? So normally, these are the reactions, the enlarged reactions. But since we have presence of greenhouse gases such as chlorofluorocarbons, what happens is that these two processes will be altered and will have additional reaction that will start destroying our ozone. Let's take this reaction, wherein your X would represent a halogen. When a halogen reacts with O3, which is very probable because O3 is a radical. You have learned this in organic. So a radical reacts rapidly as long as there is an available molecule. So if the X reacts with O3, you have the formation of XO. Then the XO will join the other process, which is the destruction of ozone. And normally, this would occur. Okay? However, class, the formation of XO is what is our concern. If you let X be any of the halogen that are present in any of the greenhouse gases, specifically the man-made ones, you will be forming the XO, for example, ClO or ClO and O2. What is ClO and O2? Normally, if you would research its characteristic, it's inert. And therefore, if it's an inert compound, it's stable, right? So the Cl is technically held in the compound. However, this ClO and O2 will keep on increasing or accumulating in the atmosphere, and due to the movement of the air, its location where it will be accumulated is either on the polar regions of south or north. Now, in those regions, what do you know? Recall your knowledge in weather or in climate. At the polar regions, you have 6 months, 24-hour directly facing the sun. If that is happening on the north side, the other side would have 6 months of 24/7 as night. So the problem is, if the ClO and O2 accumulated on a certain part of this polar region would be hit by the sun continuously for 6 months, 24/7, your ClO and O2 will now be broken to HOCl. Now, what is HOCl? This HOCl is actually a compound that is being utilized in the production of bleaching powders. So you know how a bleaching powder works, or a bleaching cream. So that would get rid of the first layer of your skin so as you will be fairer. So you imagine that the thin layer of atmosphere would have this compound, and therefore you are slowly eliminating each layer of this very thin layer away. Now, what's the intensity of HOCl? It has been studied that the impact of Cl, it reacts, or it needs to react 100 times before it is removed in the atmosphere or becomes an active compound. So that means you must have 100,000 molecules before the chlorine released from HOCl stop reacting. So that explains why you already have the hole as big as Antarctica. Now, take note class, it's not only chlorine that is present. In order for you to have what we call reservoir, these reservoirs which are being held in the polar regions and then will be eventually struck by the sunlight, it's not the only thing that you have. The X is not only chlorine. You also have bromine, and this is the news about bromine. For fluorine, no problem because it's found to be very stable and no known impact on ozone. But for bromine, 10 to 100 times more effective than chlorine. So recall, chlorine has 100,000 times ability to react with any molecule near it. You multiply it to 10 or by 10 and by 100, that is the capacity of bromine to destroy the ozone layer. So, for that reason, methyl bromide as fumigants used in agricultural industry as well as halon as fire extinguishers are already being banned due to a protocol called what we call Montreal Protocol. So countries come together to ban any manufacturing, any selling, and any trading of this type of